Assalamualaikum and good morning everyone. We are Group RAS1202F. Today, we will be presenting our innovation project entitled Rotating Solar Food Dryer. I am Nordaini Busaina and together with my group members, Fatin Norima Shahirah, Nor Imanisa and Nor Shafiqah, we will explain the application of rotational mechanics and thermal physics in our innovation. Thank you, and let's begin our presentation. Drying food is one of the oldest methods of food preservation. However, traditional sun drying methods often result in uneven drying, contamination from dust or insects, and require frequent manual turning of the food. To overcome these problems, we propose a rotating solar food dryer that utilizes both rotational mechanics and thermal physics to improve the drying process. Why do we need this? First of all, uneven drying. Standard setups keep food static, creating cold spots and damp layers as the sun moves. The rotating dryer constantly shifts the food, ensuring 100% uniform heat and airflow on all sides without the need for manual flipping. Second, food contamination. Open air drying exposes food to dust, rain, birds, and insects. This innovation uses a fully enclosed screen chamber that completely locks out pests and debris, ensuring hygiene and food safety. Third, long drying time, which is low drying causes mold growth and nutritional loss by trapping heat through the greenhouse effect and rotating the food for maximum sun exposure. This system speeds up evaporation and slashes drying times by 20% to 40%. And lastly, weathering dependency. Traditional drying is ruined by sudden rain or overcast skies. The insulated, waterproof design of the rotating dryer buffers against bad weather, protecting the food and utilizing trapped ambient heat even when the sun goes behind clouds.
This slide shows the design of our rotating solar food dryer. The product consists of 5 main components, which are the solar panel, transparent cover, rotating trays, motor and base frame. The solar panel is installed at the top of the dryer and functions to convert sunlight into electrical energy. The transparent cover allows sunlight to enter the drying chamber while trapping heat inside to increase the temperature. Inside the chamber, there are several rotating trays used to place food items such as fruits, vegetables, or fish. These trays are connected to a motor that rotates them slowly to ensure even exposure to heat and airflow. So finally, the base frame supports the entire structure and provides stability during operation. Now, let us look at how the rotating solar food dryer works. First, sunlight passes through the transparent cover and enters the drying chamber. At the same time, the solar panel converts sunlight into electrical energy. The electrical energy powers the motor, which rotates the trays slowly. As the trays rotate, all the sides of the food receive equal exposure to sunlight and warm air. The heat inside the chamber causes moisture in the food to evaporate into the surrounding air. As a result, the food dries faster, more uniformly, and more hygienically compared to traditional drying methods. This process improves drying efficiency while using renewable solar energy.
Thermal physics is also applied in this innovation. Solar radiation enters the transparent chamber and increases the temperature inside. Heat is transferred through radiation, conduction, and convection. The warm air surrounding the food accelerates the evaporation of moisture from the food surface. Consequently, the drying process becomes faster and more effective. All of these processes are calculated using the heat energy formula, which is Q equal to MC delta T, where we calculate the energy required based on the food mass and specific heat capacity to get the perfect temperature change.
For this slide 6, I will explain the application of rotational mechanics in our rotating solar food dryer. Rotational mechanics is important because it allows the drying trays to rotate continuously during the drying process. The rotation is powered by a motor which generates torque. torque is the turning force that causes an object to rotate, and it can be represented by the formula T equals to Rf, where T is torque, R is the distance from the axis of rotation, and F is the applied force. In our product, the motor applies this torque to the rotating trays, causing them to rotate around a central axis. Instead of remaining stationary, the foot continuously changes position as the trays rotate. Another important concept is angular velocity, which refers to the rate of rotation by maintaining a relatively constant angular velocity. The trays can rotate smoothly and consistently throughout the drying process. This continuous rotation provides a major advantage in traditional drying methods. Some parts of the food may receive more sunlight and airflow than others, resulting in uneven drying. However, in our product, the rotating motion allows all food items to receive a more uniform exposure to heat and airflow. As a result, moisture is removed more evenly from the food, improving the overall drying efficiency and helping to produce a better quality dried product. Therefore, the application of rotational mechanics plays a key role in ensuring a more effective and uniform food drying process. For this slide A, I will explain the advantages of our rotating solar food dryer. The first advantage is that it uses renewable energy. The system is powered by solar energy, which is naturally available from sunlight. Unlike fossil fuels, solar energy can be continuously replenished and does not run out. This makes our product a more sustainable solution for food drying. The second advantage is energy efficiency. Since the solar panel provides the energy needed to operate the motor, the system requires very little or no electricity from external sources. This helps reduce energy consumption and can lower operating costs, especially for long-term use. Another advantage is better food quality. The rotating trays allow food to receive heat and airflow more evenly, resulting in a more uniform drying process. In addition, the transparent cover helps protect the food from dust, insects, and other contaminants. This can improve the cleanliness, hygiene, and overall quality of the dried food. Finally, our product is environmentally friendly because it relies on clean solar energy. It produces no harmful emissions during operation. This helps reduce environmental impact and support sustainable development. Overall, the rotating solar food dryer offers several benefits, including the use of renewable energy, improved energy efficiency, better food quality, and a more environmentally friendly drying process. These advantages make it a practical and sustainable innovation for food preservation.
In conclusion, the rotating solar food dryer is an innovative solution that combines the principles of rotational mechanics and thermal physics. The rotating trays ensure uniform exposure to heat, while the solar energy provides a sustainable source of thermal energy for drying food. This innovation improves efficiency, reduces energy consumption, and supports environmentally friendly food preservation practices. That's all from our group. Thank you for your attention.